limited values, okay, smaller values. In this situation, we have to take only the first term, limited values. So what are those values? This will give us the r into delta theta, the first term of series of delta, sine delta theta. That means delta theta, the first term. So r square, this will be r square into sine delta theta square. It will be delta theta square. R square into delta theta square. Okay, this is whole sine square theta. Okay, sine square delta theta. Sine square delta theta means the first term will also be a square one. Okay, so this is plus sign. This r cancelled out, initial first one, minus, it will be with, okay, with plus sign here. This is cos delta theta, delta r, okay, into r square, r cancelled out, so this is delta r square only, because this is the one, the first term will be 1 minus something. 1 means delta r square only. This is delta r square. Cos delta theta, if we open in series form, this is only not a square, but this will be single one. I mean, after that it will become whole square. That means 1 into delta r. That means delta r whole square. R cancelled out. This r and this r will be cancelled out because this is 1 into this. Okay, the first term. Then delta r. Okay, the first term will be delta r whole square. Then only delta r will require, because if we multiply to 1, cos delta theta is open as 1 minus delta theta whole square upon something. Okay, so then 1, which is 1, if you multiply to r per delta, that means r per delta only, minus r cancel out, delta r is left over. Then delta r, we have to take the first term in case of these limited value delta r, delta theta, only the first, okay, term we have to take. So this delta r whole square will be there. So these are the two terms here. Now this is value of delta c. Okay, so let me further take here. If I divide it by delta theta in case of limiting position, when q tends to p, so when q tends to p, okay, in the limiting position, in the limiting case, so delta theta tends to 0 in that case. So delta theta tends to 0. I have to divide it delta c upon delta theta. Okay, therefore delta c upon delta theta. Okay, we have to describe, but let me write here delta c upon delta s. If I find out what will be that, that will give us delta c upon delta theta. If I, because we have to divide by delta theta. This is delta c. Let me write here delta theta is 0. That means delta c upon delta theta in case limiting position when delta theta tends to 0. Okay, so this will give us, let me write here delta theta divided by delta theta whole square. It will give us limit delta theta tends to 0. Okay, delta theta tends to 0. This will be under the square root. Under the square root, if I take delta theta, or let me write these two, r square into delta theta whole square plus delta r whole square. This is delta r whole square divided by delta theta only in the denominator. Okay, so if I take inside this square root, then it will become square as well. It will be delta theta square upon delta theta square. That means limit delta theta tends to 0. This is only r square. Why? Because delta theta square upon delta theta square inside if I take, and this is delta r upon delta theta whole square. Sorry. So delta r upon delta theta square. This is what we have to find out. Okay, so the value of delta c upon delta theta is this. This means ds of dc upon, or delta c upon delta. Let me write here in limiting position. In case of limiting position, okay, limit delta theta tends to 0. Delta c upon delta s we can write into delta s upon delta theta we can write. Delta c upon delta s, we have divided by delta s, multiply by delta s, no change. So this is equal to, again, limit delta theta tends to is 0, and the square root, this is r square plus delta r upon delta theta whole square. That will give us this delta c upon delta s is 1. We know this. This is nothing but ds upon d theta. ds upon d theta is equal to, in limiting position, this is r square plus dr upon d theta whole square. This is the value of ds upon d theta. Whenever ds upon d theta is to be calculated, that will give us r square plus dr upon d theta square. Okay, this is one of the formula here. So in case of polar coordinates, polar formula is ds upon, this is ds upon d theta is equal to, okay, so this is, let me take another point here, ds upon d theta is equal to r square dr upon d theta whole square, that we have described here. In this situation, now let me take another formula. Therefore, ds upon dr can also be easily calculated. What will be that? That will be r into, because this r square into dr, d theta upon dr, that will be plus 1. This will be 1 here, because dr, we have to divide this whole by this one, which formula? This one, by delta r square. If I take delta r in the denominator, delta r square will be cancelled out. In the square root, this is 1. This is r square into delta theta upon delta r. This will be the formula for in the formula. So similarly, we can obtain the second formula, and right here. Similarly, we can obtain okay, ds upon dr is equal to, this will be under root 1 plus r square into d theta upon dr whole square. Why? Because we have to divide it now d by dr square. If I divide this by dr square, the formula r square d theta square plus dr square, or delta r square, divided by delta r square, this will be 1. This will be r square into delta theta upon delta r whole square. This is what? This is a formula for ds upon dr. These are two important formulae for polar coordinates. Okay, so in case of polar formula, we have these two formulae. This is, we have taken ds upon dr and ds upon d theta. This was equal to r square plus dr upon d theta whole square. These two formulae, this is first one I tried, this second one I tried. These are two important formulae in case of polar coordinates. Okay, so polar coordinates, this is what we have. Now some corollaries or some axioms in limited position. When this alpha tends to phi, then tan phi, tan sin phi or cos phi is equal to what? Let me take sin phi is equal to how much? So when q tends to p, and right here when q tends to p, this is corollary number 1. Okay, corollary number 1. Okay, that when q tends to p, in that situation, okay, sin psi, let me take sin phi, sorry, this phi angle, when this q tends to p, in that situation, this radius vector and tangent will be only there, because this chord will assemble the tangent line. So it will coincide with the tangent line. In the tangent line, if I draw this tangent line, this is the tangent. This tangent will become as a chord. In that situation, alpha angle will become to phi angle equal to phi angle. So sin phi equal to limit q tends to p. That situation, it will be sin alpha. That means what is sin alpha in this situation? In that situation, we will have QR upon, again, so QR upon OR. That means QR upon OR. Limit q tends to p. Sin alpha in that situation will be QR upon OQ. So QR upon OQ. Okay, so QR upon, or if if I take PQ, QR upon PQ, it can also be taken. What is QR here? In that situation, QR will be, okay, first I have to grab what is the QR, but in this situation, this is the right triangle only, so this will be not OQ, but here I have to take only QS, sorry, PQ, we have to take only PQ, but QR is what? R plus, QR is R plus delta R, into sine delta theta, divided by PQ, that means PQ is delta C, in case of PQ is delta C. So if I describe this is the limit Q tends to P, Q tends to P in this situation. In this situation, this is delta C. Now if I describe this delta R, so R into sine delta theta and delta R upon delta C. So this is the situation. In that situation, delta R, okay, R to delta R, because Q will not be there, delta tends to 0. This will be R into sine delta theta. So it will be when, because delta R tends to 0 then delta R will not be there because Q will occupy position of P. In that situation, only this angle, this right triangle will be there. Then PQ will be after delta R, that means only R into sine delta theta will be there. Let me describe this. In limiting position when Q tends to P, it will be only R into sine delta theta, okay, upon delta C. If I write it as delta C, delta S, if I divide it, let me describe it again. We limit Q tends to P, R into sine delta theta, sine delta theta upon delta S orbital into delta S upon delta C. So this is delta S in the numerator, delta sine delta theta upon delta S into delta S upon delta C. Let me write it here. That will give us, what is that value further? That will give us limit Q tends to P in that situation, R into sine delta theta, divided by delta S. If I write in place of delta S as delta theta, it will be delta theta upon delta S, because here it was delta S, but delta S was further divided by delta C. In limiting position, when delta S upon delta C is 1, sine delta theta upon delta theta, and delta theta tends to 0. Delta theta tends to 0 because Q tends to this, delta theta tends to 0. In this situation, delta theta tends to 0. When delta theta tends to 0, in that situation, the delta theta tends to 0. Okay, delta theta tends to 0, sine delta theta upon this, it will be, let me write here, R, limit delta theta tends to 0, sine delta theta upon delta theta, this is 1, into limit delta theta tends to 0, this is nothing but delta theta upon delta S, and this is 1, into 1, but delta S upon delta C is 1. From assumption, we have assumed that delta C is the length of the arc, delta C is the length of the chord. In the limiting position, they will be equal to 1. The division will be 1. Okay, this is what we have taken. Now, so this is R into only this R d theta upon ds. This is value of sine phi. Sine phi is equal to R d theta upon ds. This is sine phi. Sine phi equal to R d theta upon ds. But in case of cos phi, similarly we can obtain what is cos phi then. Cos phi will be equal to, because in case of cos phi, R delta theta minus R, it will be, this length will be R per delta R minus R. Okay, so cos into cos delta theta, limiting position cos delta theta is 0. Okay, in that situation, cos delta theta is 1 and delta theta is 0. that will be R per delta R minus R, only delta R is left over. That will be delta R, which is dr upon ds only. We can prove this that cos phi equal to dr upon ds by sin phi equal to r d theta upon ds. This is what we have obtained these two formulae. If I square them, squaring these two, this implies that we should write it here. We're squaring and adding these two. What do we get? After squaring and adding these two, this is first one that we take. Okay, this is second one. Squaring and adding sin square phi plus cos square phi is equal to these values. This is r square d theta upon ds whole square plus this is dr upon ds whole square. Okay, so this is equal to 1. So 1 is equal to, we write first dr upon ds whole square plus r square into d theta upon ds whole square. This is third equation we have obtained. Third formula we have obtained. First was ds upon d theta, dr upon ds upon dr, okay, ds upon d theta, ds upon dr. Now this is another formula. This is 1 equal to dr upon ds whole square plus r into d theta upon ds whole square. So this is one of the important formula here, d theta upon ds whole square. Okay, this is the third formula. Now if I find out what is cos phi equal to, directly can be obtained. But cos phi, this is phi angle. So cos phi can be obtained from tan phi, which we know. What is tan phi equal to? If I grab these two formulae of sin phi and cos phi, which we have obtained here, sin phi here obtained r d theta upon ds. Okay, d theta upon ds here, and cos phi was obtained as dr upon ds. This we have obtained here. Okay, so dr upon ds and d theta upon ds we have obtained. So these two values we have obtained. Okay, now let me grab these two formulae from. These formulae can be obtained. These can be obtained directly from tan phi. B can be obtained from tan phi. We know what is tan phi equal to. Know that this is r d theta upon dr. This we know. Okay, tan phi. Now, if I find out cos phi, then cos phi is equal to how much? 1 upon secant phi. Tan phi, that means cos phi equal to this in terms of tan phi, or this is 1 upon secant psi, secant phi. Secant phi is 1 upon under root 1 plus tan square phi. Okay, so this can be written as 1 upon under root 1 plus this is r d theta upon dr, r square d theta upon dr whole square. This is whole square. Okay, r d theta upon dr whole square. If I divide it by dr upon d theta, okay, so dr upon d theta, if I divide it, so it will be dr upon d theta. Okay, so it is okay, tan square psi. Now if I take LCM of this will be dr square, and taken to, because cos phi is this dr upon ds, so we have to divide it by dr upon ds. If I have to take in the numerator, that will be equal to, let me check whether we have to grab this or not. Okay, dr upon d theta, if I take it as dr upon d theta, it will be dr upon d theta and upon ds upon d theta. Okay, so do we have to do this? So if I take dr upon d theta, divide numerator and denominator by dr upon d theta, it will be dr upon d theta. But this is what value? This value is of, okay, ds upon d theta. This is what value? This value is under root, square root. This is the value of ds upon d theta. Okay, so this will give us, if I divide this whole value, this is dr upon d theta in the numerator, okay, and this whole value is of ds upon d theta. So ds upon d theta we have derived, okay, we have drawn that this value is of, but in that case this is ds upon d theta from here, yeah, ds upon d theta. In this case d theta cancel out, dr upon d theta. Okay, so second side, if I take this value is of ds upon d theta in the denominator, or if I take it in the denominator, it will be d theta upon dr by, let me, how it has come, let me take this value in the denominator. So this is 1 upon ds upon d theta. Okay, so this is d theta upon ds, or d theta upon ds. So d theta upon ds, this was the value of this one if in terms of ds. So if I multiply this, ds upon dr, ds cancel out, so d theta upon dr, d theta upon dr. This is also the value of sin psi. Okay. So dr upon, so cos psi equal to dr upon ds, cos phi equal to dr upon ds, I think this is dr upon ds, I'm sorry. This is the value dr upon ds only. In the denominator we have obtained ds upon d theta, but that was in case when we have taken dr upon ds in the numerator. Well, in that cos phi 1 second side, okay, that I have taken, but this is under the square root 1 tan square psi, tan square psi is r square into d theta upon dr whole square. Okay, this is there. So if I divide this or multiply this by, we have produced this tan phi. Okay, so this value is of d theta upon dr. This was the whole square root of this dr d theta whole square plus r square, dr d theta whole square plus r square. Okay, so in the denominator, this was not the value of ds upon d theta. This was ds upon dr value. I'm sorry. This value, because dr is the denominator, so this is the value of ds upon dr. I'm sorry. This is the value of ds upon dr, this whole value. ds upon dr, I'm sorry. This is not of d theta upon dr, ds upon d theta. This whole value, because dr we are dividing d theta by dr. Whenever ds upon dr is to be calculated, this is upon dr. This value is of ds, so this will be dr upon ds. This is the value of cos psi. Cos phi can be obtained as this way. So this we know, this is the value of ds upon d theta. We have calculated. I'm sorry to say, this value is of, so from cos phi can be obtained from tan phi also. This also proves this is nothing but 1 upon ds upon dr. So this value is of ds upon dr. So in the denominator we have dr. Whenever denominator is having dr, that means ds upon dr. Which is dr upon d theta, then ds upon d theta. This is the formula we have obtained. So this is also from this formula cos phi. If I have to find out sin phi, let me find out sin phi also directly. We know that sin phi is equal to tan phi, if I write, into cos phi. If the value of these two are right here, r tan phi is r d theta upon dr. This we know. This is dr upon ds. Okay. The dr cancel out. So r is sin phi is r d theta upon ds. This is this formula r d theta upon ds. Directly we can obtain from these terms also. Okay, so this is the corollary. Second corollary we have taken. So these formula are also there. Corollary number 1 and 2 we have taken. Okay, now second formula is the sin phi is, we know that what is sin phi. Sin phi p is equal to r sin phi, this we know. Okay, from if p is the length of the perpendicular, okay, drawn from this pole to the tangent, okay, perpendicular, and this perpendicular length p is given by r sin phi. We know about it from coordinate formula. So sin phi is going to be therefore P upon R. So cos phi, if I write down what is cos phi, then cos phi we know that is 1 minus sin square phi. It can be replaced. Cos phi is going to under root 1 minus this is p square upon r square. This is p square upon r square. This is nothing but r under root. This is this is under the square root. This is r square minus p square upon r only. So if I have to find out secant phi, this is cos phi equal to this value. Secant phi will be secant phi 1 upon cos phi, that means r upon under root r square minus p square. If I have to find out secant phi, that will give us opposite of this r square upon r upon under root r square and minus p square. Value of secant phi cos phi is this. Is in terms of p and r. Length of p and r is respect in terms of p and r. So we have to, we can draw, this is second corollary we are trying, corollary number second. Corollary second, this we are trying the sin phi equal to p upon r, or this is p equal to r sin phi. From this we obtain sin phi equal to p upon r. In that situation, in terms of p and r, if we have to draw, then cos phi can also be obtained, sin phi in terms of sin phi, tan phi can also be obtained the same way. Tan phi is dy upon dx, but dy upon ds into ds upon dx can be written as, then substitute the value of dy upon, this dp upon dr, or d theta upon dr. Okay, so in terms of secant phi is this much. Secant phi we have obtained, this is secant phi, ds upon dr. What is secant phi here? ds upon dr. Cos phi, we know that this is dr upon ds. This is dr upon ds. This is ds upon dr. Secant phi is nothing but ds upon dr. It's opposite of this. ds upon dr in terms of r and p, if we have to drive, this will be r upon r square p square. This is dr upon ds is equal to this. And ds upon dr is this. For ds upon dr we have to find out in terms of p and r. And in case of sin phi, if I have to draw, this d theta upon ds, ds upon d theta, in that situation, what will be the value? If I find out what is d theta upon ds, so if sin phi, we know that is p upon r equal to r into d theta upon ds. We have to find out ds upon d theta. ds upon d theta, ds upon d theta equal to r square upon p. This is value of ds upon d theta. ds upon dr is r upon under root r square minus p square. These are the corollaries, second corollary. We have tried. Okay, so we have drawn the sin phi equal to, you know, this sin phi will be p upon r. But p is equal to r sin phi, this we know from length of the perpendicular from pole to the tangent. From this formula, we can obtain what is value of ds upon d theta and ds upon dr as well in terms of r and p. The second corollary, this we have obtained the value of ds upon dr and ds upon d theta in terms of r and p. Okay, so that is one of the other requirements. This is how we have taken the polar formula and Cartesian formula. All these formulae are to be used to draw these or to solve these questions. Let me take enough questions here. What are the questions here? Let me take first question. What is the first question say? Question said for the cycloid, x equal to this, y equal to this, we have to find out what is ds upon dt, ds upon dx and ds upon dy. Okay, so let me take question number 1. Let me solve question number 1. This is for the cycloid, x equal to a into 1 minus cos t. This is parametric equation here. And y is equal to, this is a into t plus sin t. Okay, so there are two equations. Now let me find out differentiating them with respect to t. Differentiating this, let me take first, this is second. Differentiating first and second, with respect to t, we get this is dx upon dt equal to a constant minus cos t is minus sin t, that means plus sin t. This is nothing but sin t, a sin t, and dy upon dt, differentiating the second one, it will give us a into 1 t differentiation with respect to t is 1 sin t is cos t. Okay, therefore, the first we have to find out what is ds upon dt. We know that what is ds upon dt. Therefore, ds upon dt, this we know. So this is square root of dx upon dt whole square. This we know. Into dy upon dt whole square. This is the formula for ds upon dt. Okay, so ds upon dt, the first one. ds upon dx, we have to find out. That we will calculate. But ds upon dt, first we have to find out in terms of dx upon dt. This we know. Now substituting the values. Here we have to substitute the values of this. What is dx upon dt? This one is a sin t. That means a square into sin square t. Value from this and this. So substituting these values of dx upon dt and dy upon dt from these in this equation. Because this is required here. A square sin square t plus this one. This is a square into 1 plus cos t whole square. I can take a common throughout, so a out of the square root. We will get sin square t plus it will give us 1 plus cos square t whole square if I open plus 2 cos t. Okay, this is sin square t plus cos square t 1. If I write here, this is sin square t plus cos square t in bracket plus 2 plus 1 plus 2 cos t. Okay, so this will give us a under root, this is 1 sin square t plus cos square t, 1 plus 1 plus 2 cos t. That will give us a equal to a 2 plus 2. If I take 2 common, within bracket it will be 1 plus cos t. Okay, so this is this value. Now further I have to solve it. Let me write it here. It will give us a okay, under root, this is 2, 1 plus cos t is 2 cos square